Hello everyone, let's discuss the significance of CRGO steel. So before the discussion of that, first we have to discuss what is the shape of silicon steel. Later we will discuss what is CRGO and what is the abbreviation of that CRGO. So the basic structure of silicon steel is body centered cubic structure, which means body centered so this is the cube. So body centered cubic structure, body centered cubic structure. So which is nothing but there are 8 atoms at 8 centers of the cube, and an atom is present at the center of the cube. Sorry, there are 8 atoms which are present at the edges of the cube, and one atom is present at the center of the cube. So let us say this is the structure of silicon steel grain. So this is called as silicon steel grain. The structure is what? Body centered cubic structure, that is 8 atoms at the corners, one atom at the center. Okay, so the permeability of core depends on magnetization of core, means we have to provide some heating arrangement. So why we need this magnetization? Before, for example, if the magnetization is absent, obviously the magnetic domains which are present randomly in the some segment of core. So in order to get some alignment with respect to each and every domain, obviously we have to provide some magnetization. So why we need this magnetization? In order to get the required flux. So for that there are 3 ways to magnetize the grain. So first one is what? Along any one of the cube edge, or along diagonal of same faces, or along diagonal of opposite faces. So let us say so these are the atoms which are present at the corners of the cube, and one atom is present at the center of the cube. So first point is what? Along any one of the cube edge. Before that, first I would like to notate A, B, C, D, E, F, G, H. So along any one of the cube edge. So cube edge means what? Let us take this. Cube edge means what? Either this edge or 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 this edge. Any one of the edge. Let us say this edge through AB, this edge, or let us say through this edge through CD, or this edge through BC, or this edge through EF, or this way. So along any one of the cube edge. Okay. Second one is what? Along diagonal of same faces. Let us consider this face ABCD. This is one of the face. So along the cube edges means what? Along the cube edges means what? Between A to C or B to D. Between A to C or B to D, or C to A or A to C. Here AB, BC, CD, DA, you can say EF, GF or FG or GA or etc. Okay. So second one is what? Along diagonal of same faces. A to C or C to A or B to D or D to B. Only one face. Or you can choose E to G, E to G, G to E, or F to H, or H to F. So these are the second point observations along diagonal of same faces. So next one, along diagonal of opposite faces. Along diagonal of opposite faces from A to E, or from B to F, or from G to B, or from H to D. Along diagonal of opposite faces. Let us say A to E, or E to A, or B to F, or F to P. So etc. So like this you will get different combinations from one edge to another edge, or from one diagonal edge to another diagonal edge. So in order to magnetize the core, we have three ways: along any one of the cube edge, like that along diagonal of same faces, like that along diagonal of opposite faces. So among these three, which one is higher? Whether it is along cube edge or diagonal of same face or diagonal of opposite faces, that we have to write. So the grain offers high permeability if it is magnetized along any of the cube edge. So if the magnetization is along the cube edge, obviously we have to get more permeability. So when we have to get the minimum permeability, the grain offers least permeability if it is magnetized along a diagonal of opposite faces. So in this case we are going to get maximum permeability, but coming to least permeability, we have to get least permeability when the magnetization is done along diagonal of opposite faces. So for that, so along cube edges means what? Mu, the permeability of AB, which is more than permeability of AC, permeability of AD. So AB is what? Along cube edge. Second one AC. AC is nothing but what? Along diagonal of same faces. Along diagonal of same faces. That is the second one. and the least one is what? Along diagonal of opposite faces, AD. Sorry, not AD, AE. It is AE. AE. Like that. Coming to excitation current, that is IAB, which is less than excitation current IEAC less than IEAE. IEAC is what? Yeah, IEAC. So if the permeability is more, obviously the excitation current which is required to get the required flux is very less, right? These two are inversely proportional with each other. If mu is proportional to 1 by I, excitation current, right? So mu is what? Permeability, magnetization. Like that, I is what? Excitation current. So along cube edges we are going to get the maximum permeability. So in normal silicon steel, grains are irregularly distributed, that is orientation of grains are different. So different grains offers different permeability. We all know that before the magnetization all the magnetic domains are randomly distributed. Obviously the net flux should be or maybe equal to 0 due to cancelling of different domains. So let us say along cube edge, this is the one of the cube and this is the placement of another grain, this is the placement of another grain. So let us say, so along cube edges we are going to get the maximum, right? Maximum permeability. Therefore this is what? High mu. Let us say this is grain 1, this is grain 2, this is grain 3, this is grain 4. So along cube edges this is also high permeability, this is less mu, this is also less mu, right? So this is direction of magnetization. Means you have to provide some magnetic field, magnetization along cube edges. This is one of the cube, right? This is the direction of magnetization along cube edges. So this offers high permeability, this offers high permeability because this direction and this direction is same, right? That's why this grain and this grain offers high permeability. But coming to grain 3 and grain 2, the direction is not matching with this grain direction. Obviously they are having less permeability. This is silicon grain. So in normal silicon steel, grains are irregularly distributed, therefore the orientation of grains are different. So different grains offers different permeability. So what is the importance of CRGO steel? So by using heat treatment, the orientation of all grains are made to be in same direction such that grain edges are made to be in parallel to the direction of application of magnetic field. So the effective permeability increases. So this whole process is called as cold roll grain orientation, CRGO, and the material is called as CRGO, CRGO, cold roll grain orientation. So in this the orientation of grains is different. 1, 2, 3, 4 are constant. The orientation of 1 and 4 is same. The orientation of 2 and 3 is same. So what we have to get more amount of flux, obviously we have to provide some heating arrangement. So obviously by after providing heating arrangement, due to this magnetization, these grains should be aligned in same manner. Obviously, if they are aligned in same manner, we are going to get the aiding nature of flux. Means the cumulative amount of flux is generated that is responsible to get more EMF. This process is called as cold rolled grain orientation, and that steel is called as CRGO steel. So for that, how we are going to get? So this is the silicon steel grain. So due to heating arrangement, the all grains are distributed in same manner, right? What is the application of magnetization? This is the application of magnetization or direction of direction. So this direction is matches with the application of magnetization. Same direction. Along cube edges, we are going to get maximum permeability. Grain 1, 2, 3, 4. So obviously, high mu, high mu, high mu. This case high mu. Therefore, net permeability is increases. Net permeability is increased after heating treatment. After heating treatment, this is the orientation. Sorry, this is CRGO steel grain. CRGO steel grain. So that's why in this CRGO steel has more amount of permeability compared to silicon steel. That's why it is used in the transformer core. Now we have clear idea. We have discussed significance of silicon steel, significance of CRGO steel. So coming to silicon steel, CRGO steel is having more permeability. So this is more preferably used to manufacture transformer core. Now we will discuss the magnetization curve of different magnetic materials. So let us say on y-axis we have magnetic flux density or flux. On x-axis we are having magnetic field intensity or excitation current. Okay, therefore these are the different magnetization curves of different magnetic materials based on their conductivity or based on their permeability. So let us consider first one. This is for CRGO steel. So for CRGO steel we have more amount of flux, like that. This is for silicon steel. The second best material is what? Silicon steel. And third one is what? Mild steel. And this fourth one is what? Cast steel. last one cast iron. The first best material to manufacture transformer core is nothing but CRGO steel. What is CRGO? Cold rolled grain oriented material. Second best material is what? Silicon. Like that we have mild steel, cast steel, like that cast iron. So for same field intensity, we have some important point. For same field intensity or excitation, CRGO steel has more flux density. That is, for example, phi is equals to, we all know that BA, right? So in order to maintain same flux or constant flux, the amount of B and A. So obviously in any case we are going to get maximum flux density, right? Maximum flux density. So in order to get constant flux, obviously what is the area of the core? The area of the core should be decreased. To get constant flux, what is the required parameter? More flux density. But the coming to area, that is very less. Always required is what? More flux density. So by using CRGO steel, the size and weight of the transformer can be decreased more. Note, by using CRGO steel, the size and weight of transformer is decreased compared to all other materials. That's why the superior material is what? CRGO steel. This is the significance of CRGO steel. For same excitation current, so for same excitation current, CRGO steel B is equals to 1.6 Tesla to 1.8 Tesla. For silicon steel, what is the value of flux density? That is from 1.0 to 1.4 Tesla. Right? This is about the significance of CRGO. What is cold rolled grain orientation method? So before magnetization, all the magnetic domains which are present or all grains should be randomly arranged. So after heat treatment, the all grains should be arranged in same manner or arranged in aligned manner. So obviously the net permeability is increases, which leads to more value of flux. This is the important, that process is called cold rolled grain orientation, and the steel name is nothing but CRGO steel. This is the significance of silicon or CRGO steel. Thank you.